Welcome to this short recorded video that is on the solutions to the activity, a very prime activity, within the Part B lecture notebook of the third module. So in this activity, I am not using any NumPy or anything, so I don't necessarily have this to run, but you should generally have this, imported at the start of all the lectures. So let's go ahead and do that now. I'll jump to this activity. So in this very prime activity, you are to create a function called common underscore divisors that has two parameters, x and y, which should both be of type int. The function should check that their types are correct. The function should determine all the common positive divisors of these two integers, store the results in a list, and return the result, meaning the list, to the user. You should test your function on some x and y parameters for which you know the answers to make sure it is running correctly. In this case, you should also check that you're getting the right error messages, if you're checking the right return the right values, the instances of the variables. So we want to define common divisors, and we want x and y to be the two parameters. That's it. Now, we want to check if both of these are of type int. If they're not, then something the user should be told. So if not, let's say we want to use the is instance, x is of type int, and let's say and is in instance y int. So what we're seeing is x an integer and is y an integer? If either one of these is false, right, then this whole thing is false, and that means that this is true and that I've recorded an error. So I want, if this is not the case, that both of these things are true, then what I want to print to the user is something like, we do not compute common divisors for non-integers, okay? And so then return. You can put a return right there. Otherwise, right, in this case, this didn't happen. So you should be able to say, hey, congratulations. We will put a exclamation point. Congratulations. Both x and y are of type int, and the common divisors, let's go ahead and bring this down here. Let's say will now be computed. And just to make it a little, I don't like super long lines of code. So there you go. We'll put this down here so you can separate it across. You can just check right away. Does that work the way I've done this? So common divisors, and let's say if I give 2 and 3, I have this, congratulations. In fact, maybe I want a new line here. Maybe I want to say new line. There we go. So now, congratulations. Both x and y are of type int, and the common divisors, oops, notice I should have a space there, will now be computed. And if I gave it like a 2.5 and a 3, I should get some problem right there. -2 should also work. Yeah, okay. However, I don't have any of these common divisors computed yet. It's quite simple. I say store them in a list, right? Check to see, everything that's in the list. So divisors, I'm going to create an empty list, and I'm going to append to that list all the common divisors I find. So for I in range, so in some sense we know actually like some of the common divisors, we already know 1 is a common divisor for these. Right, 1 is going to divide every single integer. So, but we'll leave it blank because we'll search for this. So for I in range from 1, which will be a common divisor, but we'll just go ahead and we're not looking for efficiency here. We'll use the min function that's built into Python. We'll check the minimum of x and y plus 1. And we do this because with the range, if we don't do the plus 1 here, this will go up to, but not including the minimum of x and y. And by going up to the minimum of x and y, you're checking if x divides into y. Now, if we're allowing this, okay, the function should determine all the common positive divisors of these two integers. X and y may be negative. So what you should also do is check versus the absolute value of x and y. So you're going to check to see if possibly x or y divides into the other if one is smaller than the other. And one of them should be. I mean, if you're giving it a number this as itself, then that's not very interesting, but certainly the code should work. At any rate, I'll just go here. By adding to the 1, we're making sure that we actually go up to and include this value. That has to do with something with the Python indexing and the range function. That's something that's discussed elsewhere in the videos. So we now check if x divided by I, the remainder of x divided by I, that's what that percent sign gives you. If the remainder of x divided by I is 0 and the remainder of y divided by I is also 0, that means that I, as you're going from 1 up to and including the minimum of the absolute value of x and y, you are now checking if there's no remainder, if I perfectly divides into these integers. If that's the case, it's a common divisor because it's divided into both. It's divided into this and this. Now, it is not a bad idea to put some parentheses. They're not necessary, but by putting parentheses around these things, it makes it a little bit more readable. It's this logical check and this logical check, those two conditions, and together, I think the parentheses just help. If that's the case, I want to append I to this list of advisors. And then I say the function should determine all of them, store the results on a list, and return the result to the user. Now you could print it here. You could say print, the common divisors of x and y are, and then I would probably put it on a new line, and then put the divisors here. That's a simple way to print it out. And then you should also then return the divisors. Oh, and I want to have that there. There we go. So if that print command was inside the if with this tab where I had the spacing here, so it's indented, this would happen. This would be printing it out at every iteration of I. In fact, I'll leave it there and you'll see the annoyance of this. So if I now print it, look at it, it says common divisors of x and y are 1. Common divisors of x and y are 1, because it was looping through I from 1 to 2, because 2 is the minimum of 3. And you can see how annoying this would get if I went to, like, let's say 20 and 30. Look how it just keeps like doing this at every iteration to check like what I is. So if I only want it to be printed once, it's better to do it that way. Now I'm returning divisors, so there's an output here. So if I put a semicolon here, which suppresses the output, notice that goes away, and this is the printing. It's a little, I think tight in here because of the print command. So maybe you want to add some, new lines, some blank lines in places, just for the, printing to be nice. So that looks good. And then you should run this with different ones. Check out like common divisors of 20 and 30, 1, 2, 5, and 10. That checks out. The same thing should be true for negative 20 and 30. 1, 2, 5, and 10. And again, if I don't want the output of this divisors as it's returned to users to be printed to the screen, then I just do that semicolon to suppress that output. So there you go. Yeah, I've returned divisors. I'm not assigning the output to anything, and I'm just printing it. If I wanted to store it, I would have to assign the output to some array or some list, excuse me. But that should work. You should check it with some positive, negative integers, and also check it. Show your checks with, make sure you show checks where things don't work. Like if you gave 5.5 and 6, that should not work. Common divisors, let's say 5, 5, let's say 3.2, that should also not work. So things like you should show that you're checking the types, that's working correctly, and that this is working correctly for different types of inputs. That's it. That's the whole activity that you have to do solo, besides the summary activity within this lecture notebook. So I'll stop the video there.